today with one of India's top fashion e-tailer, Myntra. To give us that, I invite Mr. Narayana Pattipati, Principal Architect, Myntra, onto the stage.
Good morning. My name is Narayana. I work as a principal architect for data and ML platforms at Myntra. Today I'm going to talk about how we are using real-time data and AI to kind of make fashion available to India. These are purpose statement. Essentially, India is a country of 1.4 billion people who have dreams, aspirations. We want to support their dreams and aspirations by helping them express themselves and be part of their journey. And how are we going to achieve that purpose? We want to democratize fashion by leveraging technology. And coinciding with this theme, we are going to I'm going to talk about how we are going to use technology, real-time data, AI to essentially support billions of aspirations. Now I'll go through some of the use cases where we leverage AI. For any fashion e-commerce companies, personalization and providing curated content, curated shopping experience, right from discovery to adding items to cart, the wholesale experience, post-purchase experience. It's very key. We have a lot of focus in personalization for all our users at scale in real time. India is a diverse fashion destination. We have different cultures, different regions, different cohorts. One personalization or cohort level personalization doesn't work. Users want personalization individually. That's what we do. And we also provide let's say if you are a new user and we don't know about you, we also help personalizing at cohort level. And we need to make all these personalizations and recommendations made available in the entire shopping journey. That's what we do. Let's look at some more use cases. And this is where as I mentioned, personalization at cohort level when we don't know much about you, and personalization at individual level, that is n equal to 1 personalization when we know a little bit about you, right? Now, for cohort level personalization, we use various attributes. It could be location. It could be, let's say, metro versus tier 1, tier 2. It could be, let's say, region, North India, South India, East, West. Then we have affluence. Like we have a lot of customers, let's say if you look at affluence as a cohort, there are affluent customers, there are value-seeking customers. So we can actually personalize content based on the affluence as well. And then there are purchase frequency attributes like, is it a new user, is it a loyal user, or is it a user who, let's say, churned from platform and are they coming back? And then we also leverage demographic attributes like male or female and Gen Z or millennial. These are the cohorts that we also leverage to personalize the shopping experience. And coming to individual, now any journey of personalization starts at cohort level, and then we want to actually personalize for individual users. Now coming to individual personalization, if you look at it, we have user activity. We know what users want, we know their intent. Then we have, we know about the product, we know about the trends. Then combining all the data, we process the data and then provide various recommendations. Now if you go to Myntra app, there are bunch of recommendations which you may or may not be aware of, implicitly helping you actually discover the right products, discover the right styles to match your intent, and make your whole shopping experience better. Now, you can look at, there are a bunch of recommendations that will come, and if you go to our home page, there are a lot of, there's a layout, there are a lot of widgets, right? And a whole lot of content. And that whole content is actually personalized for you. And that happens in real time. And search is also very important for us. So if you go to Myntra app and let's say search for a particular item, let's say kurta, right? The whole search experience is also personalized, right from let's say auto suggestion, right? Let's say kurta for there is an auto suggestion that is personalized for you, and the whole listing of all the products and sorting them is all personalized. That's how we always strive to use data and AI to kind of personalize and make the whole shopping experience better. Now for individual level or n=1 personalization, we have user-based attributes, product attributes, trend attributes, speed, what is the preference, based on the products that are available for, let's say, single day or next day or, regular delivery. We also personalize based on the payment choices that user, prefer. And of course, some of this personalization also happens as a batch, and in some cases, it happens NRT, and we make a conscious call on, when to make, what personalization available, either as a batch or near real time. Now, how do we deliver this, personalization across, various touch points? If you look at Myntra app, right, we don't have multiple apps. It is a single app, but we have app-in-app experience. So if you go to, if you launch Myntra app, you see Myntra, Forward, and Lux, right? So Myntra is your traditional, Myntra experience. Forward is our Gen Z focused experience, where you have Gen Z focused trends and fashion available there, and for affluent customers who are looking for luxury items, right? And there is a separate homepage experience. Now there are about 20 different recommendations that are available on the homepage itself, right? And these are powered by various machine learning, deep learning, and AI models. And they are placed, they're kind of available as widgets or banners. And another thing that we are also started working and we made available is algorithmic store. For example, as I mentioned, you have a layout of the page, and then you have various widgets. Now, we can actually personalize the content that is displayed to you. For example, let's say there is a display ad. The ad content can be personalized. So we use computer vision and other technologies to actually, take a let's say image and then customize that for you, right? And the placement of the whole widgets is essentially what we need to do is we also need to actually maximize for, let's say, engagement, maximize for let's say revenue per user, or maximize for, say, visibility of some tail end styles, etc. So we also leverage a lot of reinforcement learning where we optimize, right? It's not just displaying, we also need to optimize the experience for, let's say, improvising conversion, for example, or improving our RPU, right? So that's what we do in algorithmic store. And as I talked about search and list pages, there are a lot of recommendations. And then product display page itself has, about 10 recommendations overall. And, we are one of the first, fashion e-commerce companies to launch conversation shopping assistant. What we wanted to do is, in a chat-like interface, we wanted to actually take our customers, from discovery to identifying the right products they want to buy and the whole sale experience. So if you look at that, conversation interface, We use ChatGPT, we use OpenAI 3.5, and then, let's say you can type, I'm visiting Shimla, right? Then the prompt goes to OpenAI, then you get generic, search queries back, and then those are fired against our, search interface. And products are listed for you, and then you can actually select the products right there, add to the bag, and then go to the bag and purchase. So the whole experience is actually done in a chat interface. And there are much more, many more, experiences coming. For example, if you look at this, right, every session is different. We also want to persist the session, right, so that when users come back, they don't need to start from beginning again. So Maya is one of the use cases where GenAI is leveraged. And then size and fit is very important for fashion, any fashion e-commerce companies, because the returns are more, and that's where we want to reduce the returns. So how do we do it? So we know the user's purchase history, we know the user profile also. For example, if I have a single account on Myntra, I purchase, let's say I use the same account for purchasing for my entire family. So there are children, there is a spouse, so you have different profiles. So how do you actually, provide size and fit recommendations for different category of fashion, for different profiles? That's a problem statement that, we solve to essentially reduce the overall, returns, right? And the video is not displaying. Essentially, if you go to Myntra app, I don't know how many of you can see. If you go to Myntra app, you go to any style. In real time, you can see size recommendation, right? If it is either it is top wear or bottom wear or men or women, you get size recommendations. And in some cases, we also seek user inputs. Users actually provide inputs, and those inputs also are leveraged, and we kind of create features, and then we have a machine learning model that actually recommends the size in real time. And that's about the user experience. However, once the user, let's say, places the order, there's a lot of supply chain optimization that need to happen, right? For example, if you have to deliver some item in single day or next day, or if you have to deliver items on a same day, lot of supply chain optimization also need to happen, and we leverage machine learning and deep learning. For example, some of the use cases for machine learning are pricing, right? Pricing is one of the key problems for us. We leverage machine learning there. We also leverage, machine learning for route prediction. For example, what is the best route for delivering an item, and also we have promise, right? We on the same page when you are actually, adding a product to the cart, there is a promise, right? And based on the promise, we need to actually identify the right route or right FDC and DC to deliver the product to the customer as per the promise. So there also we leverage machine learning. And of late we are also leveraging GenAI for improving the overall customer post-shopping experience. Let's say if customer has certain challenges with returns or whatever, they can actually call our chat agent, and chat agents get this chat summarization done. And there is also at the end of the chat or conversation, there is also a sentiment analysis done, and we leverage GenAI for it, and it's already available to our CC agents. Now we have seen use cases across user experience, supply chain, then customer care. How does it all happen? The magic happens with real-time data and AI. We have pretty we have been a tech-focused organization from day one, and we have systems that are in place to capture data in real time, and we leverage AI for enabling all those applications. Let's see how does it happen. We have various data sources. There are millions of users that are shopping on our app, web, MWeb. and these events are flowing in real time. There are clickstream events. That is, user activity comes as a clickstream event. It's billions of events per minute. Then we have transactional events. We have a lot of databases. These transactional systems, we do CDC, right? Change data capture from these transactional systems like MySQL, Mongo, Cassandra, Aerospike, and all these data sources are, we capture the data, we ingest the data from these data sources into our data platform. We have a fairly modern data platform. We use Databricks Delta Lake as our lake house. And the processing happens in both. We have separate pipelines for real-time processing and batch processing. And we store the data into real-time databases and a lake for batch processing, and power various use cases like user experience. That's what we have seen, supply chain management, service experience, and of course a lot of business decision. I mean, Myntra, at Myntra, a lot of business decisions happens based on the data. We are a data-driven decision-making company. A lot of business reports, dashboards, and insights are powered either as a batch or real time. Those are also powered by data and AI. Now, let's look at, we've seen a lot of AI use cases, right? And this is a reference architecture for how we make the magic happen. I talked about one use case where you, let's say, go to Myntra app, you search for a, let's say, t-shirt, and it provides recommendations in real time, right? Size recommendation in real time. How does it happen? So this is the reference architecture. So as I mentioned, we have clickstream data coming in from app, web. We use Kafka to stream all these events, and these events are actually processed in near real time. Our end-to-end lag to process an event, for personalization is under 1 minute. And these events are processed, and the processed events are stored as features or embeddings or vectors into online feature stores. I don't have a, do I have a? Okay, oh no, I want to go back. Okay. Yeah, these features are stored in our online feature store, right? This online feature store is very important for any online machine learning use case, because you have stream of events coming in and you are processing them at very high speed, under 1 minute, lag, and you need to actually make all these features available in real time and load them into online feature store. And when it comes to batch, we have data from operational stores. Batch processing happens, and batch features are stored in, of course, batch data, that is, our golden data is stored in, data lake. And we have a lot of batch feature pipelines running, let's say at a frequency of either half an hour or 1 hour or daily. And these batch features, machine learning features, are loaded into our lake again, which acts as our offline feature store. And in some cases, what happens is, for a given machine learning use case, you may need certain features in real time and certain features in, let's say, batch. And however, for a real-time use case, you need all these features available in a real-time, feature store. That's when that load happens. So from offline feature store to online feature store, we load the data and make all the, features available for real-time inferencing in the online feature store. And of course, for our data scientists to train, they use offline feature store. They use the offline feature store to train the models. They evaluate the models on the offline feature store. And these models are deployed for inference as batch or, online. And now, if you look at the whole architecture, right, you have data sources, and then you have data platform, and then machine learning platform, and then application integration, right? And based on the use case, for example, size and fit recommendation in real time, what we do is, we expose this online inference as an API endpoint, either, REST or gRPC, and applications integrate. And typically the latency expected is under 50 milliseconds. The moment, let's say I go to Myntra app and load a PDP page, the recommendation should be available to me, or any other recommendation, right? Now what happens in some cases is, in that 50 milliseconds, we need to actually fetch the features, do the inference, and then, send the response back, right? That entire process has to happen within 50 milliseconds. So what we do in some cases is, let's say there are some complex models, there are some multi-arm bandit models. So I talked about a use case where we optimize the layout, right? It's a multi-arm bandit model, and typically the latency for some of those models is high. It's higher than 200 milliseconds in some cases. So what we do is, we also do async inference, wherein, the first recommendation goes from cache, but the moment the first user visits the first time, we send a request to the backend service to essentially get the next recommendation and store it in cache and make it available. So there is a async inference also. There are various patterns. Either the inference happens inline completely, or inference can also happen async. So we use various patterns to essentially serve our applications under 50 or 40 milliseconds. And I also talked about ML platforms, right? ML platforms play a key role here because data scientists always keep experimenting. They'll always, let's say there is a new paper, somebody will read the paper, he'll just develop a model, and then they go to business, and and they want to actually get that use case and deploy a MVP model. Now, one of the key challenges for ML platform is, how do you enable the experimentation? How do you track the various versions of this model? How do you store all the metadata about the model? And how do you deploy these models in very less time? So sometimes, if let's say a business asks for a particular use case, and there is a machine learning model that is available, we get a week to actually solution the entire thing and deploy the model in production along with the pipelines, right? That's where our machine learning platform helps in reducing the time to deploy a particular machine learning model or use case into production. And we've also worked on, traditionally the ML platforms were supporting traditional ML models and then deep learning models. Now Gen AI. Now we've actually extended our ML platform scope to also support a lot of Gen AI use cases and conversational experience. And we built extensions like, LLM core and RAG2 patterns, etc. into an ML platform. So that's the reference architecture, and this is where we leverage. 2 years back we started talking to Aerospike. We wanted to have a real-time data store, right, to support our lookups under 5 milliseconds. If it is a single lookup, maybe under 1 millisecond. If it is a batch of lookups, under a few milliseconds, so that we can provide the features to machine learning inference service, and we need to complete the inference under 40 or 50 milliseconds. So that's where we leveraged Aerospike, and we use Aerospike in multiple places in our entire data and AI stack. One is stream processing. When we are processing the stream of events, sometimes we have to actually store the state of the data, right? And we use Aerospike as a state store where the lookups have to happen very fast, right? And then of course, as a real-time feature store we are using, and also as a cache. And for, I talked about Maya as a use case, right? And Maya is a conversational shopping experience. We are also using Aerospike as to checkpoint the entire conversation, right? And then we retrieve the conversation from Aerospike. That's where, we use Aerospike. And it's perfect for us so far. We are also looking for a lot more use cases in, for example, we want to also look for hybrid search, where semantic search and other vector-based search is something that we are looking for. Hopefully, we can also look at Aerospike for some of those use cases. This is again, I briefly touched upon it, but this is what happens, when a request for size and fit recommendation happens, right? Let's say user comes to the mobile client and request comes to size and fit recommendation service. This service makes a call to Aerospike DB to fetch the features and get the size and fit recommendation under 30 or 40 milliseconds and send it back to the service. Now, there are few key learnings from our journey. Definitely, as I said, we have been focused on platformization. We were early adopters of modern data and ML platforms. We have our own in-house modern data and ML platforms. That is certainly helping us actually adapt to our AI journey. We have an open, flexible, cloud agnostic, vendor agnostic platforms. Of course, we use vendor software, but we always write abstractions so that we are not tied to one or two vendors. Our focus is self-serve and low code. If you go to ML platform, and if you want to deploy a model, you get boilerplate code, and you can deploy the model within few days, right? By incorporating business logic, etc. And even data pipelines, if you want to create an ML pipeline, you can actually do and deploy it in one day today. And we also have a lot of data and ML products. For example, one of the key requirement for any AI use case is A/B testing. We have our own A/B testing platform so that you can actually deploy a model, deploy a couple of versions of the model, do A/B testing, and choose the right one. And data and ML synergy. Typically, what we started off is data platform was separate, ML platform was separate, but we found that okay, we need to actually bring in data and ML platforms together. And today, if we create a pipeline, we have a framework to create pipelines. You can actually go and create a data pipeline or ML pipeline today. That's how we kind of unified the pipelines so that we bring in synergy. And as I said, our platforms are extendable to support newer use cases. So we extended ML platform for Gen AI. Then one more thing that we consciously did from the last 2 years is Microsoft has been our partner. We run entire stack on Azure. However, we partner with Databricks because we are a heavy Spark processing company, right? So we partner with Databricks. We partner with Aerospike. Confluent Cloud is one that we partnered with. Rohit is there, who has been our partner. Our entire streaming happens on Confluent Cloud today. And there are many more partners. And some of the pitfalls to watch out for are, definitely data governance, AI governance, then data quality and observability, platform metrics. For example, mean time to deploy, right? Nobody thinks about it. Can I deploy my, entire ML use case in one day, right? Or a couple of days. Some of those metrics, ideally, if we track from beginning, that will help platform evolution. Ease of use and adoption, and of course, as technologists, we always want to build, but sometimes, we'll have to actually make buy choices so that, we are agile and we are also open and we are extendable. Yeah. So that's about, how we are leveraging data and AI for, making India fashionable. This is my email ID, and you can connect me on LinkedIn, and I'll be happy to answer any questions. Thank you.
Thank you, Mr. Narayana. We request you to please remain on stage, and with that, I'd also request Mr. Avik to kindly hand over the token of appreciation to Mr. Narayana. Thank you for those insights on how Myntra leverages real-time data and AI to provide superior shopping experiences to millions of users across India. Thank you for being here with us today.